Here's a kind of a strange looking problem. I've got the square root of 5 times the cube root or third root. I'm not sure that 3 is clearly visible in this video, but that's a 3 there. So square root of 5 times cube root of 5 divided by the fourth root of 5. Alright, well, we haven't developed a rule for handling this type of problem with radicals, but our option is to go to exponents. And so let's write these as exponents, and then we can use the rules of exponents, because part of this section is also forcing you to review what you know about handling exponents. You know, when do you add exponents, when do you multiply exponents, when do you subtract exponents. Alright, so what is the square root of 5? It is 5 to the 1/2 power. And the cube root of 5 is 5 to the 1/3 power. And fourth root of 5 is 5 to the 1/4 power. So let's see what we got here. When I multiply two numbers of the same base, what do? We add the exponents. And so this is going to be 5 to the 1/2 plus 1/3. And down below I've got 5 to the 1/4. And really this is shaping up to be an arithmetic problem using fractions. 1/2 plus 1/3. Let's see, this is going to be 3/6 plus 2/6 over 5 to the 1/4. And so 3/6 plus 2/6 is 5/6. 5 to the 5/6 power over 5 to the 1/4. Now what do? Well, when you divide two numbers with the same base, then you subtract exponents. So we have 5 to the 5/6 power minus 1/4. And let's see, our common denominator there is 12. So this will be 5 raised to the 10/6 minus, whoops, sorry, mistake. Let's make that 10/12. 10/12 minus 3/12. So that becomes 5 to the 7/12. Okay, well, 5 to the 7/12. If we want to put it back in a radical form, this would be the 12th root of 5. Let me write it this way. 12th root of 5 raised to the 7th. We could raise 5 to the 7th power. It's a big number. It's not that interesting. But anyway, I wanted to illustrate the kind of a way of going between radicals and fraction exponents, and how that can be very useful in many cases. That those of you who might end up in calculus will do this all the time. You'll move from radicals into fraction exponents, because to do certain calculus operations, it's far easier to use the exponents rather than the radical form. And as it was here, because we had no really rules to guide us in handling mixed radicals like this, and so I had to go to the fraction form and deal with it. All right, let's look at another one or two of these before we close out this video. Our next example is the square root. The square root of 3x to the 3rd power, y squared, and everything is raised to the 4th power. So what happens when you raise a square root to the 4th power? Well, let's see. I'm going to interpret this with a fraction, so this fractional power. So we have 3x to the 3rd, y squared, to the 1/2 power, and then all of that is raised to the 4th power. So I changed the square root into 1/2 power. And now we're going to multiply our exponents up here to simplify. So I have 1/2 times 4 is 2. This becomes 3x to the 3rd, y squared, to the 2nd power, squared. So I'm raising everything here to the 2nd power. That means we have 3 squared, which is 9. And what's left? I have 2 times 3, so Remember, you multiply exponents. 2 times 3 is 6, x to the 6th, and y to the 4th power. So there we have it. One more example for this video. Here I've got 16x to the 8th, y to the negative 12th, raised to the, and let's make it more interesting. I'll make this a negative 3/4 to the negative 3/4 power. Alright, so where do we go with this? A lot of times in these exponent problems you have several orders in which you can do things, several ways you can do things. And so I think I'm inclined to just go ahead and change that exponent to a positive. And so when we do that, that's going to invert the entire inside here. The base is everything inside the parentheses. So this becomes 1 over 16 x to the 8th, y to the minus 12th, raised to the positive 3/4 power. So I inverted the inside. And at this point, I think I'm just going to go ahead and change that negative 12 exponent to positive 12. So by changing y to the minus 12th to the positive 12th, it changes position in the fraction. So that comes upstairs. So we have y to the 12th over 16 x to the 8th, and everything is to the 3/4 power. Well, the denominator is a 4, so that means 4th root. And I don't have to take 4th root, by the way. I could multiply some of these exponents. In fact, why don't I do that? I'm going to mix it up a little bit. And because when I remove the parentheses, two things could happen here. I could multiply the exponents. So up here it would be y to the 12 times 3/4. And this will be x to the 8 times 3/4. Now I chose that because I thought it was convenient. Because I see that 12 times 3/4 and 8 times 3/4 are going to give me whole numbers. But what about 16? This is 16 to the 3/4 power. And so we'll have to deal with that a little separately. 16 to the 3/4 power is the 4th root of 16 to the 3rd power. So I kind of mixed up what I was doing here. We could, again, it indicates the choice you have. When I remove the parentheses, I can multiply exponents, and if you can do that to your convenience, that's great. I can also apply the fact that 3/4 power means 4th root to the 3rd power. So I did that to my number 16, which was not written in exponent form. Alright, so I have 12 times 3/4. 4 cancels 12 3 times, so that gives me a 9. Y to the 9th power. And let me go ahead and take care of x. 4 cancels 8 twice. So I have x to the 2 times 3, that's 6th power. Now what about this? Well, let me work over here. The 4th root of 16 cubed, the 4th root of 16 is 2, exactly 2. 2 times 2 times 2 times 2, to the 4th power of 16. So this becomes 2 to the 3rd power, which would be 8. So y to the 9th over 8x to the 6th is our final result here.